Hello everyone, so today we're going to continue the section 2.8, the inverse function. Last time we finished at the steps of finding the inverse function. So I said we have 3 steps. The first one, we have to write y equal f of x. Then we have to solve for x in terms of y. And the last step, we have to interchange x as f inverse of x and y as x. And I give some examples for that. Today, the things I left here in this section is how we can graph the inverse function. How we can graph the inverse function. So here, the graphing the inverse function. So the main idea how we can graph the inverse function is we have to graph the original function. Suppose I want to graph the function f inverse of x. So first of all, we have to graph the function f of x. Then we have to reflect it around the line y equal x. So it's easy to graph the inverse function. We just like graph the original function. Then we have to reflect it around the line y equal x. So suppose I have, like, for example, suppose I have the graph of the function as follow. So before, like, I'm going to give a review here. So the graph of the inverse function, like I mean f inverse of x or f inverse, is obtained by reflecting the original graph of f in the line y equal x. Y equal x. So again, the graph of the inverse function f inverse, we have to graph the original function f, then we have to reflect it around the line y equal x. So for example, I mean, for that, if I want to graph the inverse for this function, suppose my original function f look like this. This is my original function. Example is here. This is my f of x. This function is my f of x. Here, f of x. So to graph the inverse function of f inverse of x, we have just reflect this curve around the line y equal x. So the line y equal x is this. It's the line like this here. This is this line. This is my mirror. This y equal x. I'm going to use different color. This is my line y equal x. So we have to reflect all points in this curve around this line. This line is my y equal x. Y equal x. So the reflection point should be like this. Here is the graph. So this point would be like this. No, it's not nice, like here. So this is my mirror. So the graph should be something like this. So this is the graph of my function for my inverse function is f inverse. Here, f inverse of x. We should to know one thing here. So the distance from this until the y equal x is the same as the distance from the y equal from this. I mean, like the distance from this point to this point is the same as the distance from this point to this point. And also, if I want to graph any line, I mean the line here, line for example here, same idea. I should to know the distance from this point to this point here is the same as the distance from this point to this point. Is it clear here how we can graph the inverse function? Okay, so let me give example for this. So for example,
I'm looking.
here, yes, thanks. So the example is graph the function f of x equal the square root of x minus 2. And we have to find number one, find the equation of the inverse function of f inverse. Second part is sketch the graph of f inverse. So I have two things here. I have my function is the square root. Suppose this is my square root. This is my square root of x minus 2. And I need to find the equation of the inverse, f inverse. And also I need to sketch the graph of the function f inverse. Okay, the first part, find the equation of f inverse. Who will do this one? This is like a review by using the steps. So let me remind the steps. The steps, first one, we have to write y equal f of x, solve for x in term of y, and interchange x as f inverse of x as y, and I mean like x as f inverse and y as x. So who do the first part? Is A. Anyone would like to do the first part?
Going to be y is equal to root over x minus 2.
Yes, exactly. So y equal the square root of x minus 2. Okay. Second step, this is the first step. We have to solve for x in term of y. We have to make the equation x equal something. So what we should to do here?
Professor, this part I forgot. Sorry.
Yeah, so we have to solve it in term of for x in term of y, like x equals something. I mean.
Oh yes. Yeah, I remember.
What we should do?
X interchange of y. So is it going to be? So
square the both sides. What you're going to get?
Y square is equal to x minus 2.
Exactly. Y square equal x minus 2. Then add 2 for both sides.
Y square.
What you're going to get?
Y square plus 2
plus 2 equal x. So I solve it for x. in terms of y. So I can write this as x equal y square plus 2.
Oh yes, yeah, I remember. I'm so sorry, Professor. I
Okay,
totally forgot.
that's fine. So now x equal y square plus 2. Now we have to change x as f inverse and y as x. This is the third step. The third step, we have to change x as f inverse of x and y as x square plus 2. So this is my inverse function. Here is my inverse function. Now let's graphing the inverse function. First of all, we have to graph the original function, this one. So here is my Cartesian plane, like this. I will use the black color here. Here is the black color. So this is my Cartesian plane, the x-axis and the y-axis. First of all, before we start graphing this one here, f of x equal the square root of x minus 2, can someone tell me what is the original function? What's the original function here? So I need to graph the function f of x equal the square root of x minus 2. What is the original function here? Square root of x square, square root of x to the minus 2, x minus 2. Now, first of all, before you graph this one, to know what is the original function, how like as we learned before, we're starting by graphing the original function, then we do some transformation, like in 2.6. In section 2.6, we learn, first of all, to graph something like this. We have to know what is the original function. Then we like modified the original function. Then we start graphing. Yes, exactly. Gilan, square root of x. This is correct. So the original function here is the square root of x. This is what we start by graphing this function. So my original function is the square root of x. Now, what we should to do for this one, how we can modify the original function to get something like this, square root of x minus 2. What we should to do for the original function here to make it similar to this square root of x minus 2. What we should to substitute here instead of x, instead of this x, to make it x minus 2. Here, what we should to put. Any idea? Minus 2, do you mean like x minus 2? X minus 2 like this? If we put x minus 2, we're going to get O of x minus 2 equal the square root of x minus 2. And this is similar to this. And this is f of x. So this is equal f of x. So I can graph f of x as graphing the original function O of x minus 2. Then what we have to do? We have to do shifting 2 units. Because the 2 here, it's inside the parentheses. This is like review 2.6, section 2.6. Because the 2 is inside the parentheses, this is mean we have to shift the original function O of x 2 units to where? Up or down? Left or right? So first of all, we have to graph the original function. This is my original function, like this. This is the square root of x. This is O of x. Now we have to modify the original function. We have to make it similar to this. We plug x minus 2. We get O of x minus 2 equal the square root of x minus 2. And this is equal to f of x. So f of x actually equal the original function x minus 2. So we have to graph the square root. Then, yes, Brian, this is correct. Then we have to shift this curve 2 units to the right. 1, 2. So this is like the graph of f of x equal the square root of x minus 2. So here I don't need this. This is the square root f of x equals square root of x minus 2. This point is 2. The graph looks like this. Any question before we start graphing the f inverse? Any question for how we, for this? This is like easy and simple. Just you have to write f of x equal the square root. You should to know what is the original function. This is my original function, O of x. This is just review. Then you have to know what you have to plug inside the parentheses to make it similar to this function. You have to modify the original function. So you plug x minus 2 inside the parentheses. You will get O of x minus 2 equal the square root of x minus 2. And this is actually is f of x. Then so f of x equal the original function x minus 2. So this is my second step. This is the third step. So this is mean we have to graph the original function square root of x. Then we have to shift it 2 units to the right. Here is 2 units to the right. It was 0, 0. Now it's 2, 0, 2, comma 0. Now to graph the original function part B, we have to graph the line. The line is y equal x. This is my line. Y equal x. This is my line, y equal x. Now you have to reflect all points in the blue curve around this line. So when you graph this blue curve, when you reflect this blue curve around the line y equal x, the first point 2, 0 will be 0, 2. So the point here should be, this is 1 and this is 2, should be here. The reflection of this point will be here, this point. This is 2. And this is 1. Same thing, here is 1 and this is 2. So the reflection of the number 2 here should be here. Now all points in this curve should be reflected like this. Make sense? So the question here for find the equation of f inverse, here we have to continue for x is greater than or equal 0 only. It's not for all x. It's not, it should be for the x starting from this 0 and more. We're not reflected in the negative side. So this is the graph here. By the graph, I have to know also the domain of or the value I should to plug it inside the function. So the red curve, this one, is the f inverse of x. Any question? for this example? What is the question, Mayesha? Can you please explain? Explain which part? Only the graph. Okay. So first of all, we should to know how to graph the function f of x equals square root of x minus 2, because this is section 2.6. So we have to know what is the original function. So my original function, as I learned from 2.6, is the square root of x. So now we have to like modify the original function to make it similar to this thing, to this thing. So to make it similar to this thing, we have to plug here instead of x the value x minus 2. We have to put this inside the parentheses. So I'm going to get O of x minus 2 equal the square root of x minus 2. Okay, now this is equal O of x minus 2 equals square root of x minus 2. Okay, this is exactly similar to this one, to f of x. So this is equal f of x. Now f of x equal the original function x minus 2. So to graph the function of f of x, this thing, we have to graph the original function square root like I graphed it before. Then we have to shift it 2 units to the right. Why 2 units? Because here inside the parentheses x minus 2. X minus 2, this is mean we have to shift the original function 2 units to the right. So we shifted 2 units to the right. This is the blue curve. Now we have to graph the f inverse. To graph the f inverse, we have to reflect the blue curve around the line y equal x. This is my line EY equal x. We have to reflect all points on the blue curve around this line. This point, we're starting at this point. This point is 2, 0. The x coordinate is 2, the y coordinate is 0. When we reflect it around the line, should be give 0, 2. Should be here. And reflecting all these points in this blue curve, it should be something like this. So this is the graph of my f inverse of x. And this is my graph of f of x. This is my line this is my mirror, the line for reflection, y equal x. That's it. Thanks. Okay, so any other question from other student? Okay, so by this example, we finish this section. Now let's go to the new section 3.1, quadratic functions. Anyone has idea what is the mean of quadratic functions? Do you know what is the mean of quadratic functions? Anyone know what is the mean of quadratic functions? Ax squared plus bx plus c. This is correct. Yes, the quadratic function is a function of the form a times x squared plus b times x plus c is a function of the form ax squared plus bx plus c. Any function of this form called quadratic function. But we have to change something here. Here I have to write f of x because now we're talking about function. So f of x equal this thing. And here's the two should move like this. So any function of this form is a quadratic function. Here we have a very important condition. The condition is a, here, this a, you see this a, must be not equal 0. The graph is a parabola. Very nice, safe. This is correct. The graph always for a quadratic function is a parabola. Okay, again, the function of this form ax squared plus bx plus c such that a not equal 0 is called a quadratic function. The graph of a quadratic function, like Seth said, is a parabola. Or I can define the quadratic function as a polynomial function of degree equal 2. And in the previous sections, I was like I define what is the mean of polynomial function. Okay. Now in this section, in the beginning of this section, we should to know how we can graph any quadratic function. Today we're going to learn how we can graph any quadratic function. So graphing quadratic functions by using the standard form. Standard form. Standard form. Okay. So graphing a quadratic function by using the standard form. Okay, so to graphing a quadratic function, we have to use the standard form. This is like the easiest or the best way to graph any quadratic function. We know the graph of any quadratic function is a parabola, but we should to know what is the vertex of this parabola. We should to know what is the x and the y intercept. And we should to know what is the minimum value and how is also the important thing, we should to know how is the parabola open, upward or downward. So here I can say, so the any quadratic function, any quadratic function, for example, f of x equal ax squared plus bx plus c. I can write it, any quadratic function, I can write it as the standard form. So here can be written of the form f of x equal a times x minus h squared plus k. So any quadratic function of the form f of x equal ax squared plus bx minus c such that a not equal 0, again here a not equal 0, I can write it as in the standard form. This is called the standard form. Here, the standard this form, this is called the standard form, helped me a lot to graph any quadratic function. So today also we're going to learn how we can change a quadratic function to this form. We're going to learn how we can change the quadratic function ax squared plus bx plus c to this form, then we're going to learn how we can graph the function. So first of all, some notes, very important notes. Here, the graph of the quadratic function is a parabola with the vertex. The vertex is h comma k. I mean, for h is this h here, and the k this k. This is the first note. Again, my h is this h. This is the h, I mean, and this is the k. So the graph of the quadratic function is a parabola such that the vertex is h and k. We have very important notes also from the standard form. If this a is positive, if this a, so here I can say if a is greater than 0, I mean like positive number like 5, 4, 2, or any positive number, the parabola opens upward. And the function has minimum value is k, or f of h equal k. Again, if this a here, I mean this a, is a positive number, then the quadratic function is opening upward to the up. The cup is opening to the up. And also in the same time has a minimum value is f of h equal k. So it is f of h, or we can say is the k, the minimum value. The same times, if this a is negative number, if this a is negative number, I mean negative is less than 0, the parabola opens downward, here downward, and the function has maximum value instead of minimum. Value is f of h equal k. So the function has a maximum value if it's negative. You have to focus for this. The function has a maximum value if the a is negative. And it has a minimum value if this a is positive. If a is positive, the function has maximum value. Okay. I'm going to graph like a sample for this. What is the mean of opening upward? What is the mean of opening downward? So here is my parabola, for example. Suppose my Cartesian plane like this, and I have the Cartesian plane like also here. So the first parabola is something like this, such that, like I said, the quadratic function, all of them opening is a parabola. All the quadratic function is a parabola. So this is my parabola. This point is called the vertex. This is my h, and this is my k. This is h, this is k. Here is the vertex. This point is h comma k. The function here is f of x equal a times x minus h plus k, and the a here is positive. A is greater than 0. This is mean the function here, the parabola, is opening upward. As we see in the graph, the function is opening upward. For the second one, suppose my graph look like this. Okay, this is my parabola. So this point is h. Here is h, and this point is k. This is k. So here is this point is the vertex point. This is a vertex. This point is h comma k. The function here is f of x equal a times x minus c. Oh, by the way, this, oh, hold on, this is square here. Don't forget the square here. Here's square. So for the second function is f of x a x minus h square. Don't forget the square plus k. And here the a is negative, less than 0. Any question? Any question for this?
Yeah.
What's your question?
So how is it less than 0 if it's way above 0? I'm saying
Again?
how is it less than 0 if the graph is
Oh,
above
okay.
0?
Okay. So this a here, do you see this a? This is not for above the x-axis or down of the x-axis. This a just work for the parabola open downward or upward. Even if it's up of the x-axis, it's fine. But this a is talking about the parabola down, opening down or opening up.
Oh, that makes sense. Okay.
Who the one who decide in which the quadrant is the vertex. So if the vertex is down of the x-axis, this is mean it should be like down. If the vertex in this quadrant should be here, if the vertex here should be here, who decides for up of the x-axis or down of the x-axis or in the negative side of the x-axis or the right side of the x-axis is the vertex. But the a here is just for how is the parabola open, up or down. That's it.
Thank you. I understand now. Thank you.
Yes, okay, no problem. Nice question. uh, any other question for this?
Professor, I have a question.
Yes.
So what about the minimum and the maximum? How can you show that in the graph?
Okay, nice. Okay, so if the parabola like opening upward like this and the a is positive, like I said, look, a is positive. So the vertex here is my minimum value. I mean, like my minimum value is k. I mean, this k from the vertex. You see the k, this one? This is my minimum value.
Okay.
If the graph downward like this, opening to the down like this point is my maximum value. And the value for this is k, this k, the y coordinate of the vertex.
Oh, okay, that makes sense.
How?
So the
Yes,
sir,
again,
the y
yes.
coordinates, the y coordinate of the vertex determines whether the
Yes,
value of maximum and minimum, right? Okay.
exactly. The y coordinate is defining the minimum and the maximum of the quadratic function. So again, look, the parabola here open upward. So this point and the a here is positive, right? The a here is positive. But look, this point is the minimum value for all curve. And the value is k, the y coordinate of order pair of the vertex. It's k. And the same things here. Look, the a here is negative, right? But the graph has a maximum value. The maximum value is this point. I mean, the k of this point, the y coordinate, the k, this k. Or I can say the y coordinate of the vertex. A vertex is h comma k, right? So k. Or I can say the k from the y axis. This is k. And the same things, this is k. What's happened when the k is negative? The function will not change. The k does not, the k here, like the main important things, like the k here does not determine how is the parabola open. The only things determine how is the parabola open, up or down, is a. So the k does not matter if it's negative or positive, will not affect to the function. Okay, Eric? So the k does not affect on the parabola. The only thing affects is the a, the value for a. The value for a decide if it's the curve open downward or upward. Now, if it's open upward like this, you have to find the minimum value. The minimum value sometimes is positive, like k here is positive, or sometimes the k is down, like in the down of the x-axis, sometimes in negative, doesn't matter. But if a is negative, look, the a is negative now here, the k is positive, can be positive or can be negative. It depends how is the graph of the parabola. So I'm going to give example to so k decide if the graph is maximum or minimum. No, the only one determine or decide the maximum or minimum is a. If a, look, if a is positive, the function has minimum, and you have to ask yourself, what is the minimum value? The minimum value is the k. K does not decide. The only one decide for the maximum and the minimum is a, the value for a. Look, read here. If a is positive, the parabola open upward and the function has minimum value. If a is the a is negative, the parabola open downward and the function has a maximum value. So a decide for the maximum or minimum is not k. The k is the value. The k is just the value for the maximum or for the minimum. The only one decide the function f of x or the quadratic function has a maximum or has a minimum is the value for a, this a, this a. Now, let me give you example and I will explain how we can change the quadratic function from this form to this form, from like the regular form to standard form. So my question, example here, consider the function f of x equal 5x squared minus 30x plus 49. This is my function, quadratic function. Why quadratic? Because the degree here is 2. Look, the degree here. Here has a degree 2. Here is 2. 5x squared minus 30x plus 49. So now the questions, one, express f in the standard form. Second part, find the vertex and the vertex and the set, the vertex 3, sketch a graph of the function f. 4, find the domain and the range of the function f. Number 5, find the minimum value and or maximum, it depends, or maximum value of the function f. Here I get question. So when the function has a degree of 2, it is a quadratic? Yes. The highest degree must be 2. But this is, look, Eric, this is here. This is not a quadratic. Why? Because you have to look into the highest degree. The highest degree here is 6. Do you see the 6? This is mean not a quadratic. So the function, if has the highest degree is 2, will be a quadratic function. Is it clear? So you're looking for the highest degree, not the function has, when the function has a degree 2, it is a quadratic? No, this is no. The highest degree must be equal to. So the highest degree here in this function is 2. Must be equal to. The highest degree must be equal to. If it's equal to 3, will not be a quadratic. If it's 1, is not a quadratic. Should be 2. Now, express f in the standard form. Okay, so I have my function f of x. I'm going to do this by myself, and I will explain step by step how we can change this to the standard form. This is my quadratic function. I need to change it to the standard form. The standard form is f of x equal a times x minus h square plus k. First of all, we have to look for the first term. The first term is this and this. So we have to take the first 2 terms. This is the first 2 terms. Then we have to factor it for 5. We have to make the coefficient of x squared equal 1. So this is mean we have to factor it for 5. I will get 5, open parentheses, x squared minus the 30 after factoring should be 6, because 6 times 5 is 30, and here we have x plus 49. So the first step, we have to take the first 2 terms, the terms that has x variable, then we should to factor it of the number in front of x squared. Why? Because we need to make the coefficient of x squared equal 1. Look now, the coefficient of x squared is 1. Now, second step, we have to complete the square inside the parentheses. So to complete the square of inside the parentheses, we should to add the value b over 2a square. And in the same time, we should to subtract b over 2a square times this number times 5. This is inside the parentheses and this is outside the parentheses. So again, the second step, we have to add b over 2a square inside the parentheses, and in the same times outside the parentheses, we should to subtract here. We should to subtract here minus b over 2a square times this number, the 5. This number 5 and here 5. So let's doing this one. What is b over 2a? The b over 2a is 6 minus 6 over 2a. A is 1. So minus 6 over 2, I will get minus 3. Square is 9. So actually we have to add 9 for both sides, for this side inside the parentheses, and outside the parentheses I should subtract 9 times 5. 9 times 5. 5. So let's doing this thing here. I will get 5. This is equal 5 open parentheses x square minus 6x plus 9. This is inside the parentheses. Outside the parentheses is plus 49. This 49 minus 9 times 5 is 45 minus 45. Okay, let's simplifying this thing here. I will get equal 5 times x squared minus 6x plus 9 plus 49 minus 45. I will get what? Plus what? 4. Okay. To make these things, the f of x here, similar to this thing, to the standard form, I have to complete the square here. I mean, like we have to factor this inside. What is the factor inside?
X minus 3.
X minus 3 square. So here I can get f of x equal 5 times x minus 3 square plus 4. Look, this form is similar to this form. So actually we get the standard form. Is it clear? Can you explain number 2 again? Number 2, which number 2 do you mean? Like here, Eric? Okay, so first of all, here I factor, right? I factor the 5 from the first two terms. So I get x squared minus 6x plus 49. I have to complete the square inside the parentheses. To complete the square, we have to add b over 2a squared inside the parentheses, and outside the parentheses, I have to subtract b over 2a squared, the same this, but we have to multiply by this 5. So here I get 5 times x squared minus 6x plus 9, because b is 6 minus 6, the a is 1, so minus 6 over 2 times 1 is 2, so minus 6 over 2 is minus 3, and minus 3 square is 9. So we're adding 9, and we subtract here 9 times 5. So now I will get 5 times x squared minus 6x plus 9, this 9. outside is 49, this 49, minus 4 times 5 is 45. Now 49 minus 45 is 4. And here I will, like everything, I will take it to the down. So I get 5 times x squared minus 6x plus 9 plus 4. Now we have to complete the square inside the parentheses. I'm looking for two numbers. The multiplication of these two numbers is 9, and the addition of these two numbers is minus 6. So the numbers are minus 3 and minus 3. So it's going to be here 5 times x. So minus 3 times minus 3, I mean for that, x minus 3 times x minus 3 will be factor of inside the parentheses, and this is equal x minus 3 squared. And this is what happened here. This is equal 5 times x minus 3, everything square, plus 4. Is it clear, Eric? You're welcome. So this is the first step. Now, first step is done. I find the standard form. This is very important here. Now I can solve number 2, 3, 4, 5 by using this form here, by using the standard form. Find the vertex. What is the vertex? Look here. The vertex, the graph of the quadratic function is a parabola with the vertex. You see h comma k. The h is this. The positive of this, we're taking the positive, and the k is this. Exactly, 3 and 4. So the vertex is 3, 4. We have to take the opposite sign of this number. Here we have negative 3, so it should be like 3, the positive 3. Okay, number 3. Sketch a graph of f. So I'm going to do number 3 in the back, new slide. So the standard form, number 3 here, we should to know the standard form f of x equal what? Equal 5 times the parentheses, 5, x minus 3 square plus 4. How is the parabola open? Upward or downward? Upward, exactly. Why it's upward, Safe? A is positive, correct. So look, A is 5. Because the 5 is positive, A here is 5. And the 5 is greater than 0. So it's open upward, something like this. Like this. My parabola open upward. But first of all, we have to know what is the vertex. So the vertex is 3 and 4. You see the vertex? 3, 4. So we have to go to the 3. So this is 3 and 4. This is 1, 2, 3. Here is 3. And here is 4. And here is 1, 2, 3, and 4. Okay, the graph, take this down a little bit. The point is 1, 2, 3, 1, 2, 3, 4. So the vertex here, vertex, is the point 3, comma 4. So the 3 should be here. And the 4 should be here. So the vertex is this point. This is my vertex. Now the parabola is opening upward, right? Because A is positive. So the graph should be something like this. This is the graph of my parabola function. This is my vertex, 3, comma 4. Here is this is 3, this is 4, this is 1, 2, and this is 1, 2, 3. Any question? Okay. So this is for the number 3. Now number 3, sketch a graph. We do this one. Find the domain and the range of the function. Who will find the domain and the range? What is the domain for this function and what is the range? Yeah, number 4. What is the domain of this function?
Is it greater than 3?
This is the domain.
I'm asking you.
Is it greater than 3?
Yeah.
I mean, like you have to look for the values of x that used to graph this function. As we see here, like if this is continue, right? And here this is continue. So I mean, all value are used here, right? Look,
All values greater than 0.
and all value here. What about this here
Oh,
also?
actually, yeah.
The
So
negatives.
all real numbers.
Exactly, because the negatives, we're going to use it here. But the graph, because I cannot graph all the values. So here -1, here -1, -2, -3, because here's continue, right? See here the arrows. This is mean continue, it goes up.
Yeah.
So the domain is all real numbers from -infinity to infinity. What is the range?
I think y is greater than 4. Wait,
Exactly.
I think so.
Nice. Yeah, this is correct. All values greater than 4. So the domain here is all these values because we use it to graph the function f of x equal 5 times x minus 3 square minus plus 4. So I can plug any real number inside the parabola. So all this is the domain. And the range is the y value are used to graph the function. So as we see here, starting from the point 4 and goes up, all this value are used to graph the function. So here is the domain is R and the range is starting from 4 goes to infinity. This is the range. Any question? Can you do challenging problems? Like what? This is the challenging problem, Eric. If I want to ask you okay, I have one question. It's challenging question. So find the x-intercept. Eric, what is the x-intercept of this graph?
There is no x-intercept, right?
Eric, I'm asking Eric.
Oh.
Do you know what is the x-intercept for this graph? There is no x-intercept. This is correct, Shop. There is no x-intercept. Okay, what is the y-intercept, Eric? If this is keep continuing here like this, it will be like this. Intersect the y-axis at what value? But where is the value exactly? What is the y-intercept? Eman, would you like to answer?
I'm not sure, but it will never touch.
It will never touch? No, it will touch. Actually will touch. If this is continuing up and up, will touch the y-axis. But at which value exactly?
Give me 1 second. Hold on.
Greater than 4? Yes, greater than 4. But what is the exact value? 49. Exactly, Islam. This is correct. Can you explain how you find it?
I just plugged in 0 for x.
Exactly, nice. Just plug the 0 for x. So the equation, the original equation is f of x equal 5x squared minus 30x plus 49. And actually this function is the same as this function. They are the same. Both of them, they are the same. Plug the 0 here. 5 times 0 is 0 minus 0 plus 49. So actually f of 0 equal 49. Like I said before, to find the y-intercept, you have to set x equals 0. Set x equals 0. So we'll get 5 times 0 is 0, minus 30 times 0 is 0, plus 49. So it's 49. So the y-intercept is 49. And the x-intercept here is, we don't have x-intercept. This is a challenging question.
So, Professor,
Yes.
so for example, we just got this equation, right? F of x equals 5 parentheses x minus 3 squared plus 4.
Okay.
And we were to find the roots. When we find the roots, the solutions would never make it true. Is that what
correct.
it is?
Correct.
Okay. I just wanted to make sure because
If you want to, yes, if you want to make this here equal, equal 0, you will not get a value. I mean, like if you want to find the root, like you said, you cannot find the root. You cannot find the value if if you want to find the x-intercept. To find the x-intercept, you have to make f of x equals 0, right? When you make f of x equals 0, you cannot find a solution for this.
so what do you call this?
This is called like we don't have a solutions. No solutions.
No solution, right? Okay.
No solutions. Yes. Okay, so no intercept for x. We don't have x-intercept, but we have y-intercept. The intercept for y, it's at the value y equal 49. Okay, let's go back to question number 5. Find the minimum or maximum. Do we have maximum or minimum for this example?
We only have a minimum.
Minimum, why? Because why? Why it's minimum?
Because A is positive.
Exactly. Go back here. If A is positive, so the parabola opens upward and the function has a minimum. If A is positive, minimum. Negative, maximum. So here I can solve this one. The function here has number 5. The function has a minimum value. Because A is equal 5 and the 5 is greater than 0, positive. So what is the minimum value here?
I
What is the
forgot
minimum?
what's. I don't remember the coordinates. I think it's 4 or 5.
It's the
4,
vertex.
5.
Yeah, so it's 4. I
What is
think.
it? It's K. What is K here? What's K?
4.
K. This is 4. This K, this is H. So 4. Done. This question is done. Okay. So we have another way to find the maximum and the minimum value. By the way, let me write the x and the y intercept. Maybe some student, they need it. So the function here, the function has y-intercept. The y-intercept by setting x equals 0. So when you set x equals 0, I will get f of 0 equal 5 times 0. So f of 0 equal 5 times 0 square minus 30, 0, minus 30 times 0, plus 49. And this is equal 49. So this is my y-intercept. Now the x-intercept, the function has not x-intercept. Why? So set y equals 0. I mean for y, like f of x equals 0. So I mean 0 equal what? 5 times x minus 3 square plus 4. Now, what we should to do here? How we can solve it? I need the value for x. What we should to do? First
Wait,
of all, we have to remove the 4 here. How we can remove it to the other side?
minus 4 on both sides.
Exactly, minus 4 for both sides. What I'm going to get here? Minus 4 equal 5 times x minus 3 minus 4 equal 5 times x minus 3 square. Now how we can, I need to remove the 5. What I should to do?
I'm gonna divide 5 on both sides. Hey, good morning. Oh, sorry, no.
Divide
How are
by
you?
5. Divide 5 for both sides. I will get 4 over 5 equal x minus 3 square. Now take the square root for both sides. When I take the square root for both sides to remove the square here, I will get error. Do you see the error? Why I get error here? What is exactly the, yes,
It's because there's a negative under the radical.
exactly. Here we have square, and like I said before, we cannot make the square root for negative number. That's why we stop. We don't have no x-intercept. That's why. So we stopped right away, and we have to write no x-intercept, because the square root of negative, no answer in real numbers. Any question? Now, let's go to find the maximum and the minimum value from the quadratic function direct without using the standard form. Now we're going to learn how we can finding the maximum and the minimum value from the quadratic function without the standard form. So finding the maximum and minimum point from points from quadratic function direct. Okay, so I mean for that,
Professor,
yes, go ahead.
I don't know if I exactly remember, but is this something like a negative b over 2a to find the x value?
Yes.
And then we can, right, yeah.
Yeah, this is correct. So to find the maximum and the minimum point here, or maximum or the minimum points from the quadratic function directly without using the standard form. So we're not going to find the standard form and doing this step. We don't have to find this form. We can find the minimum and maximum direct from this quadratic function. So the steps are here. I can say the maximum or minimum point or value for quadratic function I'm going to give you the quadratic function is f of x f of x equal ax squared plus bx plus c. This is my quadratic function. Now I'm going to find the maximum or minimum value direct. It's happen at x equal minus b over 2a for two conditions. If this a here, if a is greater than 0, the minimum value is f of this point, b minus b over 2a.
And if a is a negative number, we can change it to positive and change the signs of the other ones too. and apply negative b
Yes.
over 2a, right?
Exactly. If a is a negative, the function has maximum. Value is f of minus b over 2a. This is your question? I answered your question.
Yeah.
So look, if I have, this is my quadratic function. I did not change it to the standard form. So if this a, I mean this a, do you see this a? This a before this. If this a is positive, so the function has a minimum value is f of minus b over 2a. Minus b, this is b, and 2a, 2 times the coefficient of x squared. If this a is negative, so the function has a maximum value is f of minus b over 2a. So after this, we don't have to change the function to the standard form. We can use this step directly. I'm going to give example, and I will show how we can find the maximum and the minimum value directly. So here example. Find the maximum or minimum value for the function f of x, here f of x equal x squared plus 4x. Before I start doing this one, what is my a? What's the value for a? What is the value for b? What is the value for c?
1, 4, 0.
1, 4, and 0. This is correct. Now let's, exactly, Eric. Now this function does have a minimum value or maximum value?
It has a minimum value.
Minimum value. Why? Because
A is positive.
a positive. So my a here equal 1 is a positive number. So if a is positive, this is mean the minimum value is, the function has a minimum value. The function f of x has minimum value.
Think of
So-
it like I came up with a little something that helped me remember. If it's negative, think of the sad face. You know, curves
Yeah,
down.
okay.
Yeah.
If it's negative, like, yes, exactly. Correct. So here is positive. This is mean the parabola will be like this, open like this.
Right.
So the function has what? Minimum value. This is my minimum value, the vertex. So now, what is the minimum value? What is the value for the minimum value? The minimum value has the value is f of minus b over 2a. And this is equal actually f of, what is the b?
It's negative 4 over 2 times 1.
Negative 4 over 2 times 1. And this is equal f of negative 4 over 2 is negative 2. Now plug the negative 2 inside the function here. What are you going to get?
You're gonna get 12, 4 plus 8.
4.
No, 4 plus negative 8.
Uh,
So that's negative 4, I think.
Negative 2 square plus 4 times negative 2. And you will get 4 minus 8. 4 plus 4 times negative 2 is minus 8. And the answer is negative 4. This is my minimum value. Okay. And I can say here the vertex
Come here.
is minus 2, comma, minus 4. This is my vertex. Okay. Any question so far? Anyone has a question for this? Can you explain it again? Yes, no problem. Look, Eric, first of all, you have to write the A value. The A value is the coefficient of x squared. The coefficient of x squared is 1, but is hidden, okay? The coefficient of x is 4. This is the B value. The coefficient, the C, the constant here is 0 because we don't have C. The value for Z is 0. Exactly like this.
But Mister, I think I can explain this a little better.
Okay, go ahead.
So we use this little technique, B over 2A. Hey, give me 1 second. Let me just tell this baby to go.
Okay. I have a function of x equal 1x squared plus 4x, right, Eric?
Sorry,
Yeah,
sir. I
it's
have
fine.
kids around here. So negative B over 2A is a technique that you don't have to go into the function to find the vertex. So negative B over 2A is the x value of the vertex. So negative B, in this case, negative 4 over 2 times 1, that's the x value. That's the x value of your vertex. And then when you plug in the vertex, you find the y value of the vertex. No, when you plug in x in the function, and then you find the corresponding y with the vertex, with the x value. So it's just a little technique to find the minimum or the maximum like right away. So it's a good technique to remember, I think.
Is it clear, Eric? Or do you need to explain it more? Okay. You're welcome. So first of all, you have to check the A. If it's A positive, the function has a minimum value. If it's A negative, you have a maximum value. Okay, so we finished this section. Let's go to the 3.2. I'm going to give you like the basic idea for 3.2, and then we're going to finish for today. So 3.2, polynomial functions. Like in the previous section, we talked about only the quadratic function. Today, we're going over the polynomial, the greater and the bigger function. So polynomial function and their inverse. So polynomial function and their inverse. But I'm going just to define what is the meaning of polynomial function. What is the meaning of polynomial? Anyone know what is the meaning of polynomial function?
Polynomial
Yes.
function.
Or polynomial of degree, for example, I will like specify the polynomial of degree n. What does that mean?
Has multiple binomials.
Yes, it's a summation. Do you like it's a sum of monomial? You remember the monomial? What is the definition of monomial?
It's
What is the monomial?
a single degree term.
Single, like, can you give me the formula or the
X,
how is the
for
form?
example, x plus 2 is a monomial.
X
No?
plus, no, it's
No.
not x plus 2. But can you close to the answer, but without the plus. We're talking about the monomial.
Maybe 2x squared.
2x squared. This is correct. This is a monomial. So I can make it in general. It's the sum of the form a times x to the power k. And k must be natural number or 0. Natural number or 0. Or I can say the k here is a non-negative integer. Eric said 2x squared plus 2x can be a polynomial. Yes. Any quadratic function is a polynomial function. Any linear function is a polynomial function. So polynomial of degree n is a function of the form. So polynomial of degree n is a function of the form. I'm going to give you the form. So the polynomial function is b n of x equal a n x to the power n plus a n minus 1 x to the power n minus 1 plus dot dot dot. We just keep continuing until we arrive at a 1 x to the power 1 or x plus a 0 x to the power 0 is 1. So a 0. We should know this and this and this one and this one, all of them called coefficients. We should know all of these are called coefficients. This, all this is a called coefficients. Coefficients. And we should know this a of n is called the leading coefficient. This is just like a definition. Just to know what is when I said during this lecture, leading coefficient, you should to know this is the leading coefficient. You don't have to memorize this thing for exam, but you should to know it because I'm going to use this definition a lot during this section. So when I said leading coefficient, you should to know this is the leading coefficient. And an, xn, all of this term called the leading term. Leading term. Here without the a. Sorry for that. Here term like this. This is called the leading term with the x. The a only called the leading coefficient. All these coefficients, the a's are called coefficient. And also in the same time, you should to know this a is called the constant coefficient. Also, it's called in the same times the constant term and called the constant term. Okay, we're going to stop up to here for today, and I will see you next week. Have a good day.
Have a good day.
You too. Have a good day.
Professor, can
Professor-
you go to the last slide, please?
Yes.
Professor, the grades are gonna be in the weekends?
Yes, I hope so.